Okay, we are going to talk about solving quadratics by factoring today. So let's just go ahead and get right into it. First of all, this isn't a new concept. We've already done this before, or we've talked about it briefly. So I don't want you to think that this is completely brand new. Again, one of the most important things that you need to understand is that we are not getting rid of the quadratics, or solving quadratics part, or factoring. Remember, if you remember factoring is taking a quadratic such as this, b squared minus 6b plus 9. Okay? If we have b squared minus 6b plus 9 equals, let's just say 25. Okay, if you remember what factoring is, we need to factor, we need to have this set equal to 0. Okay, so one of the things we need to remember is set equal to 0. Okay, so the first thing I need to do if I want to factor this is move this 25 over. I've got to subtract 25 from both sides. Okay, when I subtract 25 from both sides, that leaves me with b squared minus 6b. Okay, 9 minus 25 is negative 16. Okay, e equals 0, right? Now if I want to factor this, again it has to be set equal to 0, so now we're set equal to 0, so now I can go ahead and factor this. If I want to factor this, I check to see if it has a coefficient, and we go through all that stuff, that process, using our factoring flowchart. Take out the greatest common factor, that would be step number 1. There's no greatest common factor. Then I want to look to see, do I have a coefficient in front of my very first term? I do not. That's a good thing, so I don't have to do rooftop. And so now what I would do is I would go ahead and drop down my parentheses, still be equal to 0, and then drop in my variables. Okay? Then I want to look at factors of negative 16. That equal negative 6. Off the top of my head, I'm thinking 8 and negative 2, or the opposite of negative 8 and positive 2. 8 minus 2 is positive 6. Negative 8 plus 2 is negative 6. I want this to be negative 6 because that's my OI term. Again, here's my last term. Here's my OI term. These are all steps from factoring that we should have learned last week. I know we're still struggling mightily with that. Our test results indicate that very clearly. And we're going to do some more measures, which I'm going to send out a little short video message to you guys, kind of explaining how we're going to combat that as well. So as I continue here, I find out that I want negative 6. So here's the factors that I want. So I'm going to take this right there. And then I'm going to stick it here. B minus 8 and B plus 2. So essentially, if I was looking for the factors of this, this would be my factors. Okay, those would be my factors. Okay. But we're going to add to that. We're not just going to factor anymore. Now we're going to take it to another step. We're going to actually find the solutions to a quadratic. If you guys remember, and we'll come back to this problem in a minute, but if you remember our quadratic unit, which has been a while, let's just do a quick review. What do you know about quadratics? Well, quadratics create parabolas. And again, more familiarly known as the U-shaped graphs. Okay, solutions are also called roots, zeros, and x-intercepts. Okay. May have 1, none, or 2 solutions. Okay, so those are the main things that you got to remember from that parabola, or I'm sorry, that quadratics unit. They create the parabolas, the U-shaped graphs. Okay, the solutions are also called roots, zeros, and x-intercepts, and may have one, none, or two solutions. Again, quadratics are identified by the square, the little square term. If you have an x squared, then you have a quadratic. Now, please don't get that confused with having several different things. Like, for example, just because I have x squared, y to the fourth, z to the sixth, just because I have this square here does not mean that that's a quadratic function, okay? But I want you to understand that the x squared, or the square term, does create a quadratic function. So everything that we're going to be dealing with in this particular unit is going to be dealing with quadratic functions, okay? So let's take a look. Again, a little bit more review before we go ahead and get started. If I had a graph, this is my Cartesian plane. And we're going to look at a couple different examples. If I had a quadratic that went through here, like so, my roots would be right here and right here. My x-intercepts were across the x-axis. Here's my x-axis, here's my y-axis. So my roots would be x equals 1 and x equals 3. So you have two solutions, or two roots, or two x-intercepts. Okay, what if I had a situation where I had right here? Well, my x-intercept is right there at x equals 1, 2, 3, negative 3. In this case, this would be called a double root. Anytime you only get one root, okay, because ideally we're looking for two roots, okay, but if you only get one root out of there, we usually call it a double root, okay, and that's just a very, very broad, generic, baseline information. It's called a double root. And then, of course, you have a third type of solution in which you might have a parabola here. Excuse me, that's not a good example. Maybe you have a parabola going this direction. They can be negative based on your a value. Well, if you have a parabola going in this direction, in this case, it's going to have no solution. And that is because it'll never cross the x-axis. So here you have two solutions, one solution which we call a double root, and then we have no solutions. Okay, so for the most part, it's pretty simple. We can solve these by graphing without any problem. So now we just need to work on solving them using factoring. So how do we do that? Well, let's go back to our original example, the first example that we looked at, and we'll solve that quadratic by factoring. So we had b squared minus 6b plus 9 equals 25. Okay, if you remember correctly, the first thing that we did was we got rid of that 25. We subtracted 25 from both sides. We ended up with b squared minus 6b minus 16 equals 0. Then we realized that we didn't have to rooftop, so we dropped down the parentheses, dropped in our b values, looked at negative 16, figured out that negative 16 had a value of negative 8 and 2, which equaled negative 6. We're looking for that, okay, based on our OI term. So then we threw in our minus 8 and plus 2 here. And that's where I left you at the very beginning of this video. Now, we're not simply finding the factors anymore. Now we want to actually find the roots. We want to find the solution. Where are the x-intercepts at? When you get to this point, all you have to do, and this is the easy part, factoring is still the hard part. When you get to this point, all you have to do is set each factor. So here's a factor, and here's a factor. You set each factor equal to 0. Here they're combined, but I'm going to separate them and set each one to 0. So b minus 8 equals 0, and b plus 2 equals 0. And then solve. Add 8 to both sides. B equals positive 8. Over here, subtract 2 from both sides. B equals negative 2. So my roots are B equals 8 and B equals negative 2. That would be my solution for the quadratic. If I wanted to check this, I could go back into my calculator, plug that into my graphing calculator, and see on my graph where the quadratic or the parabola is crossing the x-axis, and I will see that it's crossing at where x is 8 and x is negative 2. Okay? And these are points. If I ask you for the points, the point would be 8 over, 0 up, and on this one the point would be negative 2 over, 0 up. Okay, let's look at another example. All right, let's look at let's get rid of this one. Oh, let's look at, I don't want to do that one, that's not fun. Let's look at 4p squared plus 10p. Oh no, sorry, Ali, I'm trying to find an easier example for you. Okay, let's look at 3v squared plus 5v plus 11 equals 0. So 3v squared plus 5v plus 11 equals 0. Okay? So as we look here, first thing we want to do is make sure it's set equal to 0, which it is. It's always got to be set equal to 0. Now I want to go into my steps of factoring. So I would factor out my GCF. In this case, there's no GCF. So then my next step would say, okay, look, see if there's a coefficient in front. Is there a coefficient in front? Yes, there is. So now I want a rooftop. So I'm going to rooftop. And I'm going to get 33. Now I need to find factors of 33. That's going to equal up to 5. So that's what I'm looking for, 5. So if I start off, I have 1 and 33, or negative 1 and negative 33. Well, those are way too high. Okay. Only other one, next one I can think of is 3 and 11. Or negative 3 and negative 11, which equal 14, or negative 14. Okay. 4 doesn't go in there, 5 doesn't go in there, 6 doesn't go in there, 7, 8, 9 doesn't go in there, 10, and then we're back to 11 again. Okay, so there are no factors of this that equal 5. If that becomes the case, then you have no solution. Okay, I wanted to give you an example of no solution. It doesn't factor out. I cannot factor and simplify it more. I can't get my factors, so I can't set it equal to 0, so I can't solve for my x-intercepts because there is no solution. This is probably an example of a quadratic or a parabola that sits off into the space basically, but it'll never cross the x-axis. Okay? Okay, let's look at one more. Again, rooftop doesn't go away either, so please keep that in mind. Okay, so let's look at one more. Let's look at x. We're not going to do a rooftop example on this particular one, but I just want you to understand it doesn't go away. So let's look at x squared plus 6x plus 9 equals 0. So x squared plus 6x plus 9 equals 0. Okay? Again, let's start off by factoring out the GCF. There is no GCF. Oh, well, first of all, is it set equal to 0? Yes. Factor out the GCF. Is there a GCF here? No. Okay. check the first coefficient here. Is there a coefficient in front of that first term? No. Good. That means I can drop down my parentheses. Set it equal to 0 still. Bring in my x value or my variable. Now I need factors of 9 that add up to 6. Okay, well, 3 and 3, that's pretty simple, right? 3 times 3 is 9. 3 plus 3 is 6. That's our answer. So I'm going to put in here x plus 3 and x plus 3. Now I have my factors. Remember, the next thing to do is set those factors equal to 0. So now I have x plus 3 equals 0 and x plus 3 equals 0. Now solve for x. Subtract 3 from both sides. X is equal to negative 3. Well, common sense tells you both these are exactly the same. So even if I do this, it's going to be the same thing, which is x is equal to negative 3. This is an example of a double root. So my only solution would be x is equal to negative 3. It doesn't matter which one you circle, but this is it. This is a double root, meaning that the one solution's in the same spot. There's not two different, significantly different answers, okay? All right, so basically that's it. Not a whole lot to it. Again, you've already seen this before. Those of you who paid attention in class, or those of you who did the assignments before, because we've actually done assignments on this already, you kind of should have a heads up. This is pretty simple, nothing new, nothing too over the top difficult. If you have any questions, make sure you write those questions down. I'll see you guys on Wednesday. Have a great day.